All right, so now let's look at negative exponents. So anytime we have a negative exponent, we know that that is going to be equivalent to taking the reciprocal of the base. Reciprocal of the base, right? So 2 over 3, 3 over 2. 5 would become 1 over 5. 1/7 would become 7 over 1. 2/7 would become 7 over 2. All right, take the reciprocal of the base, and then when it's the opposite integer, so negative 3 power would become positive 3. Negative 2 would become positive 2. Negative 10th power would become positive 10. All right, and so on. So let's look at an example. All right, so I have 2 to the negative 4th power. All right, what's the reciprocal of 2? That's right, it's 1/2. So I'm going to rewrite this as 1 over 2 to the positive 4th power. All right, so what does that mean? That means I have 1/2 times 1/2 times 1/2 times 1/2. Okay, so 1/2 times 1/2 times 1/2 times 1/2 equals 1 over 16. So 2 to the negative 4th power, if we evaluate that, becomes 1/16. Let's look at another example here. So we have 4 to the negative 3rd power. We're going to rewrite that as 1 over 4 to the 3rd power. So what does that become? 1/4 times 1/4 times 1/4. All right, top 1 times 1 times 1 is just going to be 1, and the bottom is going to become 4 times 4 is 16 times 4 is 64. So 4 to the negative 3rd power is 1 over 64. Okay, same thing with 5 to the negative 3rd power. We rewrite that as 1/5 to the 3rd power. So we know that's become 1/5 times 1/5 times 1/5, which is going to be 1 over 125. All right, so 5 to the negative 3rd power is 1 over 125. All right, now let's look at when you have a fractional base. So we have 3/4 to the negative 2 power. So I'm going to put the parentheses around the 3/4. So 3/4 to the negative 2 power. That becomes, take the reciprocal of 3/4 is 4/3 squared. So what does that mean? It means 4/3 times 4/3. All right, well, 4 times 4 on top is 16. 3 times 3 on the bottom is 9. So 3/4 to the negative 2 power becomes 16/9. All right, do the same thing with 3/10 to the negative 4 power. Again, the whole thing, the whole fraction, 3/10 is raised to the negative 4th power. So that's going to become, the reciprocal of 3/10 is 10/3. So it's 10 over 3, but now that's to the positive 4 power. We know what to do with that. That means 10/3 times 10/3 times 10/3 times 10/3. Well, 10 times 10 times 10 times 10 is 10,000, right? And then 3 times 3 times 3 times 3 is 81. So we get 10,000 over 81. So again, our goal today is you're going to have a function, something like y equals 3/10 to the x power, right? And then you have to do a table of values where you're plugging in x is negative 4, x is negative 3, x is negative 2, x is negative 1, x is 0, x is 1, x is 2, x is 3, and you're getting a plethora of ordered pairs or points. Okay, and then tomorrow we'll use those points to actually graph it. Today I just want to work on, can you do the math here with the computations with negative exponents, your zero exponents, and your positive exponents. Can you evaluate those functions for different x values? That's what we're going to be doing in the practice today.